Hello all, welcome to the next lecture on electromagnetic theory and transmission line. So in the previous lecture, we have discussed the introduction to transmission line theory. So what is a transmission line and how it is different from a normal wire or a cable, and what is meant by transit time effect and when we should get the transit time effect. So in short, whenever the frequency of the signal is high or whenever the length of the cable is high, large is very large in kilometers, then we have to consider the cables that you connect also into your analysis. Okay, and the analysis of this is done through the cables. These cables into picture, and that is done with the help of transmission line theory. Okay, so in this lecture, let us start the discussion or the analysis of the things. So here we will be discussing two topics today. So first, the topic is what about the different types of transmission line. So the types of transmission lines. Yeah. So we have majorly four categories or four types of transmission lines, or the four different commercial transmission lines that are generally used. Okay. So the first of them is the traditional twisted pair cables that we use for long back in the telephone communications. I think most of us might not be seeing in the present generation, but these are the first types of the transmission lines that were used for transmitting the voice over telephone lines. So here you have the two cables overlapped like this. So twisted, right? So I take two cables, right, and I overlap them in a way, right, with the help of shielding. Each cable is shielded, right. In between, we place the shielding is nothing but the dielectric material, either paper or some kind of dielectric material is taken, right, and the two conductors are shielded in such a way that we get a twisted pair like this. So this kind of twisted pair is the first type of transmission line. Okay, so these twisted pairs or the copper cables, as they generally call, right? These are of very less in size, so low size. Okay, the size of them is very small, right? So the size of the cables are very small because you just need two conductors and a shielding material. Okay, so the size of the overall cable is very small, so you could accommodate more number of cables in less area. Okay, so that's what we generally had. Okay, but the frequency that which these signals support is also very small. Okay, the frequency supported by these cables is very small, so these are used for low frequencies, generally for audio or signals are generally used. This type of transmission lines are generally used for audio or voice frequencies. So these support very low frequencies. That's what we're discussing. So major applications are telephony, etc. So we these kind of cables are absolute nowadays. So we don't use this kind of transmission lines. Next, coming to the second type of transmission line is the coaxial cables. So many of might be seeing these kind of cables or the transmission lines. So this coaxial cable is one which we use for our dish cables in the TVs, right? For satellites, etc., etc. So whatever the dish cable you have inside your home is nothing but the coaxial cable. Okay. So coaxial, as the name indicates, so it is a type of transmission line, or it is a cable that is formed with the help of two conductors that are coaxial to each other. Coaxial means lying on the same axis. Okay, so I have two conductors lying on the same axis. Same axis is what we call it as coaxial. Okay, so the diameter or the size of the cable is different, but both of them are centered to on the same axis. Okay, so this is the coaxial arrangement. So here I have generally, right, an outer shielding which we see as a black color. The outer cover that we get, this is a black cover, the electric, which is used for isolating this cable from the environment and also for protection. So the black cable, the black shielding that we get is the outer cover, and inside that we have a first conductor which is the aluminium foil. Okay, so generally a foil which is made up of aluminium or copper is used as the second conductor here. Okay, so the outer conductor, and then in between these two, right, in between the okay, so after this we have a white asbestos material, right? That is used as the dielectric. So here the dielectric is a asbestos material, or right, you could see that white material that comes inside. That is the dielectric material. Okay, and after that we have a wire, a copper cable that is used as the main conductor. So this is the main conductor, right? So the main conductor is the rod which is there, the wire or the rod that is there inside is the main conductor, right? Over it there is a dielectric material of plastic or asbestos in white color, and over that I have an aluminum foil which acts as the second conductor, and over it we have the shielding. Okay, so this kind of arrangement is the the transmission line, which is what we call it as coaxial cable. Okay, so this coaxial cable can support frequencies up to a few megahertz, okay, a few hundreds of megahertz. So it can support up to 500 megahertz, which we generally call as the UHF range. Okay, so VHF, UHF, and right, HF frequency ranges are all supported by coaxial cables. So these are generally the most widely used type of the transmission lines. So everywhere in commercial applications, because the cost of the material is also very low, right, and the losses are also very less, right. The advantage, we have low cost, the cost of the material is less, right. It is also less lossy because of the shielding and all, right. So the lossy ness is very less, the losses are low, okay, low lossy material, right, and it can be used for long distances as well. Okay, right. So this is why it is the most preferred type of transmission line for the commercial applications, right. Everywhere, in the homes or in the set top boxes, or even in some industries also, whenever we want to transmit the electromagnetic waves of low power, okay, low power, and for medium distances we go for coaxial cables. Okay, so as I said, the applications we discussed, right. The main drawbacks, what are the main drawbacks, as I told you? So basically the power handling capability of this coaxial cable is low. Okay, so low power devices, these are low power handling capability devices. Okay, so the power that they can support is low, and also the length of the cable, right. So the length of the cable is also very less, right? Not very less, we can say medium sized cables. Okay, we can use them up to several kilometers. Okay, so beyond right, let's say 100 kilometers or 50 kilometers, the length, the line becomes very lossy. Okay, so therefore, right, we generally see that whenever we want to have dish connection for long distances, in between they place boxes which are nothing but switches or repeaters. Okay, so you need frequent signal conditioners which are repeaters. Repeaters are to be used. Okay, so this is the thing with coaxial cable. So the structure of the coaxial cable, advantages, as I said, low cost, and losses are also less for small distances. Okay, and easy to use them. Okay, and that's why we use them in the commercial applications, in all the commercial applications. Drawbacks, as I said, low power, the power handling capability of these devices is low. The length of the cables are also the support is of medium range, we cannot use for very long distances. Okay, so this is the second category, or the second type of the coaxial cable, right. Now the third type of coaxial cable, the third type of the waveguide, sorry, transmission line, is the waveguides. Okay, so right, waveguides. So waveguide is basically a metallic structure, a system, right, in which we have two metal plates, right, separated by a dielectric. Okay, so it is right, a metallic structure. You have something like this, a rectangular waveguide like this. Okay, it's a planar waveguide, or you can also have a circular waveguide. Okay, so a hollow metallic structure. Waveguide is basically a hollow metallic structure. Hollow metallic structure, right? Hollow means it is empty inside. Okay, so hollow metallic structure that is used for transmission of the electromagnetic waves from one end to the other end, right? So in general, it is constructed with the help of two metal plates, right, placed one over the other, and the air medium as acting as the dielectric. Okay, so this kind of transmission lines are called as waveguides. Okay, so the main purpose of these kind of waveguides is used, or these waveguides are used whenever we require very high powers to be transmitted. So these are very extremely high power handling devices. So whenever we want to handle high power electromagnetic waves for transmission from one end to the other end, we go for waveguides. Okay, so these are used in the military applications, in radars, right, in antennas. Okay, to connect the antenna to the load, right, or to the source. Okay, so whenever the electromagnetic wave that you are transmitting through them is of high power, in that cases we go for waveguides. Okay, so waveguides are hollow metallic structures, right? Hollow metallic structures, okay, that have two metal plates, right, or that transmit the electromagnetic wave through them. So here the principle of transmission is the multiple reflections. The EM wave transmits or propagates through the waveguide with the help of multiple successive reflections between the two plates. Okay, so right, with the help of this, it gets propagated through the waveguide. So it is a hollow metallic structure that is used for transmission of electromagnetic waves. Okay, the biggest advantage of them is they can handle very large powers. Okay, right. Whenever you need to have large power handling capability of a transmission line, you go for these structures. That is why we use them in antennas, right, in radars, right, in military applications and missiles, everything, everywhere. Whenever the power of the electromagnetic wave is large, we go for these structures. Okay, now coming to the this is the advantage, high power, so therefore we use it. So what are the drawbacks? As you can see, these are very bulky in nature, right? You need metals and a hollow space. So when compared to the other structures, these are very large in size. Okay, and also very costly to construct, right? Costly and difficult to manufacture them. Okay, and also, right, the costly increases, and the length of this waveguides that we can construct is also very short. We cannot have very long waveguides because that will increase the overall cost and size of the system by many times. So generally we don't use these waveguides whenever we want to transmit high power to long distances. Okay, so that is not possible, right? So therefore, generally the length of the waveguides used is in several meters itself, not even a few meters in right, centimeters and meters. Okay, so whenever you want to transmit high power electromagnetic waves from one end to the other end, we go for these waveguide structures. Okay, yeah. So this is the third type of the transmission line we have. Then the fourth category of the transmission line that we have, the fourth category of the transmission line, all right, is the optical fiber cables. Okay, OFCs. So these are similar to that of coaxial cables, right? Only thing is, right, this is an optical fiber. So here the electromagnetic wave, right, whatever frequency is there, so this will be converted into a light signal. That is another electromagnetic wave. Light signal is also an electromagnetic wave, but the frequency is in the range of 10 power 14 to 10 power 15. So you have this frequency range. Okay, so you convert the electromagnetic wave of any frequency into light signal, that is in this range frequency signal, and you transmit it through the right fiber. Okay, so fiber, we know there are two materials here. We have a core and we have a cladding. Okay, so the core will be generally of higher refractive index when compared to the cladding. So with the help of total internal reflection, right, the light gets propagated inside the right, inside the core. Okay, so inside the core, right, we will have the light getting reflected, right, because this at this point the total internal reflection happens at this boundary and at this boundary, and the light stays within the core and it travels throughout the waveguide, okay, or throughout the optical fiber cable. Okay, so right, this is the fourth category of the transmission line. So this is the highest frequency handling devices. So the transmission line that can handle highest frequency is an optical fiber cable. Okay, so also the length of the cable, right? Whenever we require the longest, right? Whenever we require to transmit the signals over very long distances, we go for optical fiber cables. That's why we can see nowadays, right? Whenever we want to have 4G or 3G signals, right? For 3G spectrum to be transmitted, we are going for optical fiber cables. Okay, so OFC cables undergroundly they are taking and doing it. Okay, because they can handle that large frequency, high bandwidth, and also they can transmit the signals without losses. Okay, so the losses inside them will also be less. Okay, so they can be used for this. Okay, but only drawback is again here also the power handling ability of this OFC cables is also less, so you cannot transmit high power signals through OFC cables. Okay, normal, medium, or small powers you can transmit for long distances. Okay, so these are the advantages and drawbacks of this OFC cable, optical fiber cable, which is the fourth category of the waveguides. Okay, transmission lines. Okay, so these are the four types of the transmission lines: twisted pair cables, coaxial cable, waveguides, and optical fiber cables. Okay, so we discussed each category. What are their drawbacks? What are their advantages? Okay, so that is it for this lecture. In the next lecture, we will be discussing about the parameters of the transmission line. Thank you.